tyFlow basics, the groups operator explained. Good day everybody, let's talk a little bit about groups. I'm working on a couple of tutorials and groups are starting to get involved, so maybe I should just touch on it. Grouping in tyFlow is, I don't know exactly how to say it, but it's a way of kind of filtering what particles are allowed to interact with what other particles, right? And only particles that are in the same group, right, can interact with each other. So if we kind of look at this scenario here where we got three different color balls being birthed, and we associate each color with a group that's being defined by the group operator. That means that once we enable groups, then wherever that's been enabled, it'll only be able to interact with the group of the same type. So, for example, if I birth the balls and assign them group 1, if I don't go and assign groups somewhere else in my particles, it won't interact with anything. In fact, if we just birthed the red particle and assign a group to that birth operator, the event that's controlling that, and we don't assign groups anywhere else in the whole world, alright, in the tyFlow thing, that red ball will just fall and fall for everything, including the floor, because nothing else has been assigned a group. So let's say that we want to have the red ball interact with the red bowls, right, containers here. Then we would have to assign group 1 to the red ball, and we would have to assign group 1 to the red bowl. Same with the yellow, right? Make that group 2. Now, one thing that's interesting is once you enable groups somewhere in the flow, all of a sudden, all those items that have been assigned a group will actually fall through the floor. The ground plane is normally a collider by default, but once you enable groups, you have to go into the main settings here and also enable grouping on the floor, or it's no longer a collider. So we'll go through this in Max right now, but each item can have more than one group, right? So for example, we got group 1, 2 and 3, red, yellow and blue. We want all three to collide with the ground plane. So in this case, we would actually say that the ground plane is going to be part of group 1, 2 and 3, right? So that way all three colored balls, all three groupings will actually also collide with the ground plane. I mean, that's the bare essence of groups. Only items in the same group can interact with each other, but the interesting part is you can have overlapping groups. Let's look at it in Max. So here we are inside Max for some groups 101 theory, right? And we've got the simple setup where we got 4 position icons, and each has been associated with a group. Think red, yellow, blue, group 1, 2, 3, white, no group. And that's the color that's the color scheme we're going to use throughout this group's tutorial. Red group 1, yellow group 2, blue group 3, white no group. So if you kind of think about motorcycle gangs, alright, the Hells Angels, Mongols, Outlaws, the analogy there is that they don't really interact well, right? Hells Angels don't really interact well with any other gang, right? They want to be the boss. So, you know, groups are kind of the same. If once you enable a group somewhere, it can only interact with other items of the same group. And it's to the point that where nothing else exists in the scene. Like once we enable group 1 and these red balls, if anything else in the scene isn't set to group 1, it really doesn't know about it. It's like it doesn't exist. And to add a group to a flow is as easy as coming over here, hitting your tab key and starting to type groups, and then we drop a particle group operator in there, and then we can set what group we want it to be by enabling these buttons, and you can see that the label changes appropriately. So we'll turn this off for a minute, but that's how easy it is to enable groups on something. And we'll delete this operator because we don't want white to be part of any group. And if we go in here, we can see that based on the labels, we've set red balls to group 1, yellow balls to group 2, blue balls to group 3, and down here we can see that we've set up some display operators that are also been associated with groups. So a lot of the operators actually have nice writing in the label that lets you see if grouping has been enabled. Some operators, like this physics shape, are not so helpful. So if we go into this physics shape, we can actually enable grouping here, but no change happens on the label. At some point when you've gotten a big grouping project and you accidentally click something somewhere and next minute things don't happen the way that you think they should, you might have enabled groups somewhere and not realized it, and unfortunately, like here, it's not changing the label to let you know that groups have been enabled. So just be aware of that. And there are many different operators within tyFlow that can have a grouping enabled on them. Let's get back to this example and just reaffirm what we saw in our theory. So looking at this groups project here to explain groups, it's pretty simple. We're going to drop equivalent group labeled balls from position icons that have been grouped to the appropriate groups, and white is no group. So first thing we're going to reaffirm is that once you enable groups, they don't interact unless they're part of the same group. We can see the red, yellow and blue ball fell right through the box, didn't even know it was there, and they're going to fall through the floor because the floor collider also has grouping. So once we enable groups, if we want these items to collide with the floor, we have to enable them in tyFlow main settings. So I'm going to go down here, enable groups 1, 2 and 3. Alright. One drawback to this is we've now enabled groups 1, 2 and 3. The white ball is not part of any group, and there's no options for us here to also enable no groups, right? So the white ball, because it's always going to be no groups for this example, now it's going to pass through the floor. So ideally, if we wanted to have all these 4 colors, I would have to make white, say group 4 or something if I wanted floor interaction, but for the purposes of this tutorial it doesn't matter. The other thing I'm going to do is there's a fairly big movement between each frame. I'm just going to decrease the time step so that we have more time to visualize the position of the balls on a frame. And now you can see that we've enabled groups 1, 2 and 3 on the floor, so now the red, yellow and blues collide with the floor. That's grouping in its most simplest and basic form, and that's really all you need to remember throughout. If there's one theme throughout this tutorial, is that only items in the same group can interact, period. Alright, so let's set particle group 1 here on our collider box, right? So we're going to set it to group 1, which is red. And just to help us visualize that, we're going to turn on the red. So now only the red balls should collide with the red box. And that's exactly what happens. And note that the white ball passes through the floor because it doesn't have a group associated with it, and there's no way we can set that up on the floor while there's grouping enabled elsewhere. So that's pretty simple. Now you can see the red ball is hitting the red ball here and interacting because it's a physics shape. If there was red and yellow balls on top of each other, right? They would just pass through each other. They don't know they exist, just like they're passing through the platform. So that's something you're going to have to be aware of once you enable groups. Like two particles from two different groups won't even know each other exists, so you'll get penetration and intersection. Let's take a look at a more, I don't know, realistic example of, say, a cannon shooting out a whole heap of coloured balls. A group relationship means that only items in the same group can interact. That's it. Keep that simple thought in mind when working with groups. Alright, if we look at this group example, using the same colour scheme, red is group 1, yellow is group 2, and blue is group 3. In this instance, white doesn't matter, right? It's just a way of indicating any balls that passed by these groups 1, 2 and 3. And we look at the example itself. The cannon just shoots out shapes, and it randomly assigns a group as it's coming out of the cannon, and it's kind of a cool little thing. If yellow or blue balls hit the red wall, they explode and go into pieces. If blue or red balls hit the yellow wall, and etc., etc., and only the red balls will stop and fall on the red wall, and the yellow balls will stop and fall on the blue wall, and the blue balls will stop and fall on the blue wall. And that's all controlled by groups, period. If we look at the flow, it's probably going to seem intimidating at first, and even though it's a lot of flow for little animation, right? Like, it seems like a lot of flow for what we just saw. At its very basic level, we're just birthing some particles here, right? From this position icon, we're giving it a sphere shape, we're positioning it on the icon, we're sending it out. The speed here that's been set is purely been adjusted to be whatever speed I need it for it to fly through the air with gravity still enabled and kind of hit the wall halfway up, so you can see this arcing angle. Right, so I just kept adjusting the speed until they reached my targets about halfway up the wall. That's how I determined the speed. And we turn them into physics shapes. Now we're going to give them a random material ID, and we got 1 to 3, which is red, yellow, blue. And then what we're going to do is set a particle group on these spheres, and it's going to be based on whatever the material is. So I'm doing a filter here that's saying if the material ID equals 1, set the group to 1. Here, if the material ID equals 2, then set the group to 2, and etc. So we've set a random color on our spheres, and then we set the appropriate group. And on each of the boxes, we've set the same group, right? Red box is red group, yellow box is 2, and blue box is 3. And now what we do here is we're going to test for collisions with the red box. And we've set it also to be group 1. So in other words, only spheres that are in group 1 can collide with this box, and so only red particles will end up getting sent out this connector, right? And it's the same with yellow. You see, yellow box, we've made it part of group 2. So when we do this collision test here, only either red, yellow or blue balls are going to get sent to this event here, in which case we add some gravity so they fall hard to the ground and kind of land inside that catchment tray. Now, on this second set of collision test, we can't have two kind of collision tests on the same object, because anything that is colliding here and meets that definition will go out. So if we test it on the same red box, nothing would ever happen down here, because anything related to that would have been sent out here. So what we actually got to do in this event to make this work is we create a hidden red box, a hidden yellow box. So when we look at our scene, there's a second box. It's just a clone of the first, and it's been named hidden, right, and yellow. So there's also a red, yellow, and blue hidden box. And the purpose of those boxes is to test for the opposing groups. So red was group 1, so now we're testing for group 2 and 3, which are the yellow and blue balls. So in other words, if a ball hits our hidden walls that's not the same color as the wall, then we're going to do this little activity over here, which is actually we're going to fracture the ball, then we're going to make them members of all groups, because we want any small particles that land on the ground to be able to interact. We're going to stop them from moving around because they had initial velocity from being shot all the way across. So, and then we're going to give them a little bit of gravity to send them away from the wall but drop. And then over time we're going to scale them down. So over a period of time we're just going to scale them down and make them smaller and smaller and alter the gravity a bit, alright, and then eventually over time a bit more, we're just going to make all the tiny particles come to a stop. So from that perspective, you can kind of think of this event as being a successful hit, right? Right, the right group on the right box. And you can think of this event as saying, hey, you know, wrong color hit, right? Wrong color hit, destroy, right? So, and then what the hell is this last one here, this invisible wall, right? Well, it's pretty simple. Like, turn tyFlow off for a minute and we see this white wall here, and that's what I'm calling my invisible wall. And basically when you look in the top viewport and we do the animation slider here, some balls go in between and don't hit anything, and some balls go to the left or the right. So all I'm doing there is testing any of those balls that make it past our boxes without colliding, and I'm just turning them into white so they land safely in the back of the white box and become white spheres. And just to show you that again with tyFlow off, there's my invisible white box, right? And if it collides with this invisible white box, we're just changing the material ID to white here. So, and the white box is allowed to interact with groups 1, 2, or 3. So that's kind of, I don't know, complicated, not complicated, but it's a fairly, you know, a lot of things going on in this little flow just to make, you know, a groups example. But there it is, you know, there's groups in action. Alright, here's a coil spring example. I made something similar for another tutorial, kind of testing tutorial I'll put on the web. And I am going, because I've had a couple of requests, I will actually do a separate tutorial on how to make something like this. So we're not going to go into this one because I'll confuse you about grouping. And the main point that I can tell you about this, and we'll do a simpler setup to show what I mean about how to use groups for binds, but this setup requires groups to control how binds are made because I'm using multiple binds, and I think it's a perfect example of something that you might actually use groups for in real life. Alright, I'm just going to turn on the main binds, and like I said, we're not going to go through it. So this pink one that you can see that appeared right in the middle here, that's a rigid joint, and that rigid joint is great for keeping things vertical. It doesn't allow pivoting on the bind, and what helps this thing go back up into position is these yellow binds, and they're spring binds, but they allow movement in all sorts of directions, and if you only allowed that, this thing would go all over the place. That was a bit of a deviation into binds in the middle of a groups tutorial, but the main point being here that groups are used throughout this flow to control what is allowed to connect to what. And if we go from our earlier tutorial part where we showed the containers being caught and we showed the cannonball shooting out, at the end of the day, remember that only things in the same group can interact with the other things in the same group. That also stands for binds. Only binds can connect with things that are in the same group. Let's do a simpler example than a spring. Alright, so here's a simple example of binds and grouping. I've got these boxes laid out here in an orthographic view, and the group that they're part of is listed in the handwriting I've got over the top. Nothing going on here except that for each bind. So this one here, I'm saying that it can connect to groups 1, 2 and 3. So that means that because this guy is a member of group 1, 2 and 3, and we have items up here that are group 1, 2 and 3, and distance is plentiful for any of these binding settings, and maximum amount is plentiful. So if I turn this on, we can see because this guy is a member of group 1, 2 and 3, and his bindings here, it's not just that we have this, right, but there's also an option in the binds, right? So because it's saying that it's allowed to connect to group 1, 2 and 3, you can see that the bind color is white, so we have connections being made to all the groups. So if I turn off group 2 here, you can see that it no longer can connect to group 2 just because I turned it off. Even though this guy is a member of group 1, 2 and 3, you have a separate control in the bind. So alright, so but let's say we also want to have these two cross connect, but only these two. Now remember, there's plenty of distance here, 40 and 60. Technically it could connect to anything, but we're only saying that it's only allowed to connect to group 2. So when we turn that on, and it's a blue bind, see there the color for the bind, we're only getting one connection across from 2 to 2. So this whole simulation group is controlling what binds can connect to what. Same here with group 3. Maybe we want a cross connection here, but not allow it to go anywhere else. We go here, we see we've got a red bind, and we're only saying that it can connect to 3. So only 3 is connected to 3. Now, if I said allow 1 as well, you can see that some extra lines jumped up to 1. So I'm hoping this is a more visual representation of how grouping with binds work, right? And how you can apply it. Up here, I'm actually saying that this top box can connect to any of them, but we're just going to run into a small issue. This is being asked to do so before any of these are are born, so to speak, because it's the first event. So I would actually have to jump to the next frame, and we can see the orange connection being made to the other lines. But I hope that makes it easy to visualize grouping with binds, and you can now see, maybe I hope more clearly, how depending on how you lay out all your items, you can manage how connections happen so that you can really control animations and apply different binds in different methods, all within reach of each other. Alright, so let's take a look at this simple molecule idea. So we got particles that are spinning around, made to look like a bit like some sort of molecule in space. Turn off the spline paths so we don't see those. What we're now looking at, the white lines, is the actual binds being made from the outer particles to the inner yellow. And the inner yellow is actually the only one that's got rotation applied to it. So all the outer particles are being spun and driven by the bind connection. So when we look at our setup here, we're birthing a sphere in the middle, and that's our yellow one, and we're assigning it to group 1. On the outer particles, you can see here, on the outer ones, we're assigning them to group 2. And you can see, if we expand this, you can see the group setting is nicely labeled in the title of the operator. And physics bind is also one that happens to let you know what's going on with groups. And you can see here that we've enabled group 1 on this bind operator. So what we're saying here, because of this grouping arrangement, is binds are only allowed to be made to particles in group 1, in which case there is only one particle in group 1, and that is the yellow one, which is why all of the binds only go into the middle. If I came down here for a minute and messed with our nice little setup and said also allow binds to group 2, you can now see how the binds jump between all the purpley looking balls. So even though it's a simple example, it's an effective example of explaining grouping with binds. As far as explaining the rest of the flow, in both instances we're just giving the particles a shape. We're turning the shapes into a physics shape, and then up here we are applying some rotation on the yellow one, and I'm doing 2 lots because I want this multi-directional effect, and all I'm doing there to allow that to happen is I'm staggering the timing. So when we look at the timing here, this one is set to 4 and 2, and we look at the timing here, this is set to 2 and 1, so the timing is offset, so we actually get a multi-directional spinning thing. And turn back on the spline paths, and there's our little spinning molecule based on grouping binds and controlling how connections are made. Okay, so I was searching for ideas on how to make one final groups kind of animation to just kind of finalize everything, and I kind of got this cool virus growth thing. I remembered an old project by Jesse Pilata, and I kind of went back and looked it up and just reminded myself on how it worked. And this is a fairly serious variation of that. But here's the starting mesh, and I've activated the points so we can see them. So you can see the density of the mesh, right? And I used quad remesher and made a fairly high resolution retopology of my G, and it's important to try and get roughly the sizing the same so that you get equal growth. And while we're in this screen right now, I'll just turn on this collider box. There's several collider boxes because I expanded on my G, which was for groups, and added the end. So my original one with the collider box here is, in the first few frames I position it close. So I kept it away because I didn't want the growth to start before you even see the first frame. So the first couple of frames it's moving, and straight away you can see it's being detected by the flow, which we'll go through in a minute. Now this would actually continue to grow, but from this particular spot until we've gone all through the particles, but I wanted a more cool effect where the growth starts several places at once. So over the first 10 frames I move the box to very precise positions and make sure that it's actually starting a growth, which you can see live that the growth is starting to happen. So that's how I made this growth happen from multiple locations at once on the G. And when the time slider goes forward, you can just see I paused the end from appearing till after frame 120, right? So, but you can see the idea. Now you're not supposed to see this mesh, so if we go into tyFlow and I show the window here, if we go into tyFlow and turn this off, right, and you'll see now that you don't see the mesh. Don't worry about the writing, but and that's the idea of how this is supposed to work. So the growth just slowly happens, right? So it's a fairly simple process, but you know, originally it was 30,000 particles here for the G, but then I added the end in the second flow, right, which is actually an exact repeat of this first flow. All that changes in that one is the lettering for the end. I made a different color than blues. So this screen kind of has most of the information, but you know, basically we have G, which is a very high resolution quad mesh, and then we have the colliders that jump around and get close enough, and you can adjust that live. You can actually see the growth live as you go. That's how good it is. But so basically in this event one, we birth all of the particles on the vertices, so all of them are born, and then we just turn them off so we don't see them. And then basically we're testing against our little collider cube, right? And we're testing, I think, for about 1.3 in this instance, right? And if it's within that distance, it sends it over here, and this is where everything happens that causes the virus. Originally this was just a time test event, just to delay the growth of the virus, right? So it didn't happen too fast. But I found it a good place to tweak the animation slightly, and I'll show you what I mean in a minute. But let's concentrate on the main thing here, that the group's involved. So the first thing is we detect a small amount of particles that are close to our object. Send them over here. Now we make them part of group 1 here, and the reason we do that is if we don't enable grouping till this is all finished, right, then essentially this thing would go so rapidly that you'd almost see all the particles change at once. So now what we're doing is slowing down that whole process. So here we just give it a shape, and I've just made a geosphere 20% scale. And then we spawn. Now this spawn is just creating one new particle on top of all those green vertical ones that were created over here. And then we're giving it a random material ID, and I've got 5 colors. For the G, it's all 5 shades of blue, very close to each other. And the rest is self-explanatory. So first time round, then it comes back over here, and at this point after 10 frames, this surface test actually doesn't really apply anymore, right? So because we actually moved the box away as well, and it's no longer animated after 10 frames. So now all animation is occurring because of the property test, and we're testing for neighbors of the original particles, but because we've made them part of group 1 here, right, and the core essence in this whole damn tutorial is if they're not in the same group, they're not going to interact. So you know, by putting them in group 1 over here and then testing over here. That's how we prevent like a total spread of neighbors in 1 frame or 2 frames, right? So now we can actually control it with time. So how you kind of control this animation on how fast the growth happens is right here in your time test with a variation, whatever you want to make them kind of make it happen faster or slower. And you also initially control the size of the initial growth by what size you make the collider box and how close you put it to your object. And originally that was it, only the time test existed here and we went over, but I realized that this would be a good opportunity to create some smaller particles that as they're sitting there waiting to move over to this one, become final rendered, I would actually do some that are only 10%, half of the first. So you'll actually see this waiting process before they get passed over here. And then I just made this, you see the particle, the colors are from 6 to 8. I made these darker colors so that as the growth happens, it appears to be a darker, smaller growth that then grows into our final rendering. And I've rendered it, and I'm going to put it at the end of the video. It's a really cool result. And let me just activate this and hide it. And so when we zoom in closely on this one, you can see it in real time, right? These smaller particles are that middle event I was talking about, which originally didn't get rendered and originally didn't get shown, but I like the effect. You notice how I've made those colors darker and smaller. So it really, and then what I also did was, which was a cool thing, I kind of animated this coloring seed by time. So every single frames, these colors kind of swap around and jumble around randomly, which really makes it look like this kind of virus is growing, if you can see what's going on there, right? So it's a cool effect and I really like it, and we'll leave it there on groups for today. I'll just show you the final rendering, which is really pretty. Take it easy, everybody. Bye.